Hey, sixth grade, missing your faces. Hope you guys are all doing well. We're going to move on to 9.6 in our chapter 9 right now. We're going to be talking about surface area. So we hear a lot the term three-dimensional or 3D, and it might be one of those terms that we hear a lot and we are familiar with, but we don't know exactly what it means. Um, 3D actually means that we're talking about a figure that has length, width, and height. Okay, and specifically we're going to be talking about polyhedrons. That might be a new term to you, but a polyhedron is a closed 3D figure with flat faces that are polygons. Okay, the intersection of two faces the intersection of two faces of a polyhedron is what we call an edge. Okay, and three or more edges intersect at a point called a vertex in a polyhedron. Okay, 3D figures with curved surfaces are not polyhedrons, and we have three of those that we're going to be talking about throughout the rest of this chapter. We have circular cylinders, circular cones, and spheres. Okay, we're also going to be talking about prisms, and a prism is a special type of cylinder with two congruent polygons as bases, and we have cubes, rectangular prisms, triangular prisms, and hexagonal prisms. And what these arrows kind of here mean with bases is that we said that they have two congruent polygons as bases. So this right here is going to be congruent to this down on the bottom. This up here is congruent to what's on the top. If we were doing this in class today, I would have some actual like tangible visuals in my hands showing you this, but think about like a cereal box or a box that comes from Amazon, okay, and the top and the bottom are the exact same shapes. And back here, we have this hexagonal base that is congruent to that one, okay? It's kind of hard to see this 3D stuff when we're just talking in the book, but hopefully you can get there. We're also going to be talking about pyramids, and a pyramid is a cone with a polygon as a base. And we name pyramids by the shapes of their bases. So the one that we're probably most familiar with is either a triangular pyramid or a rectangular pyramid. So triangular pyramid means at the base of the pyramid there's a triangle. Rectangular pyramid, we've got a rectangle at the base here. Pentagonal pyramid, you've got a pentagon down at the bottom. Okay, box skill check number 1 says name each figure and write the number of faces, edges, and vertices. Okay, so we're going to look at this shape and we're going to say, okay, what is this? This is a triangular prism. Okay, and we know that because a prism is some sort of a cylinder that has two congruent polygons as bases. And here we have a triangle that is congruent with this triangle right here. So this is a triangular prism. I'm going to erase that. Oh, I did not mean to just erase that whole thing though. Whoops. Let me redraw that really quick. It's not going to be as good as my other one. Sorry about that. Yeah, that's a really bad one, but that's okay. All right, so here's our triangular prism. And let's talk about the faces, the edges, and the vertices. I am going to change colors here so that we can follow along. Okay, so remember our definition of faces. Okay, and our faces are going to be one right here. We have another face here, another face here. Then there's another face on the bottom. So we're at 4 now. And then there's one in the back. Okay, there's one in the back that, again, if I had a figure in my hands, I would be able to show this easily to you. But there's 5 faces. Okay, switching colors again. Let's talk next about our edges. Okay, let's talk about our edges. And the edges are where two faces of a polyhedron um, intersect. Okay, so we have an edge here, an edge here, edge here. So we're at 3, 4, 5, 6, 7, 8, and this one here in the back, 9. So we have 9 edges. And then the last thing we want to talk about is vertices. And a vertex is where 3 edges come together, okay? So here's 1, 2, 3, 4, 5, and 6 vertices, okay? Vertices is plural for vertex, okay? I want you to tackle skill check number 1, number 2, and 3 on your own. You should get rectangular pyramid and 5, 8, 5 for number 2. And for number 3, you should get cube and 6, 12, and 8. Okay, moving right along. We're going to be talking about surface area, okay? So the surface area of a polyhedron is the sum, so we know we're talking about adding, the sum of the areas of its faces. So the surface area S of a polyhedron is equal to the area of the top and the bottom, which that's going to be 2 times the length and the width because we have both a top and a bottom, plus the area of the front and the back of the polyhedron, so 2 times the width times the height because we have 2 of those, and then 2 times the area of the sides, so 2 times the length times the height because we have 2 of those. We always like it when we can have a formula that we can work with. So the formula for the surface area of a rectangular prism is S is equal to 2LW plus 2WH plus 2LH, where L is length, W is width, and H is height. Example number 1. Robin wraps a birthday present. What is the smallest amount of wrapping paper that she needs? So here we have her birthday present, okay? And we have a height, we have a width, and we have a length. So we just get to plug those values into our formula, all right? So A is equal to 2 times length times width. So length is 5, width is 4, plus 2 times width times height. So 4 times 3 plus 2 times length, which is 5, times height, which is 3. Okay, so that gives us A is equal to 2 times 20 plus 2 times 12 plus 2 times 15. So A is equal to 40 plus 24 plus 30. So A is equal to 94. Okay, and we're talking about surface area, so it's units squared. Okay, units squared. Example number 2. Find the surface area of the triangular prism. So in order to figure out the surface area of this triangular prism, we have to talk about what shapes do we have represented in this triangular prism. Okay, what do we have here? We have 2 triangles. Oops, and I just noticed I made a little error here, so I'm going to erase that. Okay, we only have 1 bottom rectangle. Sorry about that. 1 bottom rectangle. Okay, so let's define these shapes really quick. We have 2 triangular faces here. We've got one here and then this one in the back here. Okay, this one in the back here. And then we have these 2 slanted triangular faces here and here. And then at the bottom of this, we have one rectangular base that runs kind of all through here. So in order to figure out the surface area of this triangular prism, we need to figure out the area of the two purple triangles, the two slanted, and sorry, those were slanted rectangles, the light blue ones, two slanted rectangles, and then the area of the one bottom rectangle. So let's start with our two triangles that are marked in purple. Okay, so our two triangles, okay, the area of a triangle is 1/2 base times height, right? So we have two triangles times 1/2, and the base is right here. Here's the base. The base is 16, and the height is right here, and that's 6. So 2 times 1/2 times 16 times 6, because we have two of those, okay? And I need to grab my calculator really quick, and that is 96, okay? Then we have the two slanted rectangles, which are marked in that light blue, okay? So the area of the two slanted rectangles is going to be 2 times, because we have two of them, 2 times the length times the width. So let's look. Here's the length right here, okay? 2 times 10 times the width is 3, okay? So that's 2 times 10 times 3. 2 times 10 is 20. 20 times 3 is 60. Okay, and then we have one bottom rectangle on the bottom of this triangular prism. Okay, and that has, let me just change colors so you can see it. That has a length right here of 16 and a width of 3. And there's only one of those, only one. So the area of that is going to just be 16 times 3, which is 48. Now you add all of those areas together. 96 plus 60 plus 48 is equal to 204, and this is area, centimeters squared. So we have figured out what the surface area is of our triangular prism. Skill check number 2, so box skill check number 2. Number 2, we're going to go ahead and we are going to work through that example. Just getting my calculator ready because I know I'm going to need it for this one. And let's get some colors so we can see what we're talking about here. So here we have a triangle here that is going to be the same, congruent to this triangle here. Okay, so those are going to be our pink triangles. We're going to say the area, those two triangles together, so there's two of them. Okay, area of a triangle is 1/2 base times height. So 2 times 1/2 times the base of these triangles is 6, and the height is 5. So we have 2 times 1/2 times 6 times 5. So that 2 and 1/2 goes away. And our surface area of our two pink triangles together, oops, I just realized that I did 5 when 5 was this. Scratch that. That's actually 4. See, even teachers make mistakes. So here's our triangles again. Nice and pretty pink, and sorry, this is the height of the triangle. So 2 times 1/2 times 6 times 4 is 24 meters squared. So that covers our pink surface area. Now we have we have a rectangle here in the front, and then there's another rectangle here in the back. Okay, so there's two rectangles, all right? And those rectangles are 5 by 8, because this is 5 also, okay? So they are 5 by 8. So the area of our two rectangles are 2, because there's two of them, times length times width. So 2 times 8 times 5. Okay, 2 times 8 times 5. 8 times 5 is 40. 40 times 2 is 80. meters squared. And then we have a rectangle on the bottom. Okay, we have this rectangle down here. Okay, we have that, and we just have one of those. So the area of that rectangle is length times width, so 6 times 8, which is 48 meters squared. Now we're just going to add all of those together. 24 plus 80 plus 48 is equal to 152 meters squared. I would like you to challenge yourself to do number 1 in box skill check number 2, and the answer to that one, just so you know, is 324 centimeters squared. All right, now let's find the surface area of this square pyramid. Okay, we named it a square pyramid because it has a square on the bottom, and it has, how many faces does the square pyramid have? It has 1 face, 2 face, 3 face, and 4 face. Okay, so it has 4 triangular faces and 1 square at the base. Okay, so the area of our 4 triangular faces is going to be 4, because there's 4 of them, times 1/2 base times height, times 1/2 times, what is the base of the triangle? The base is 7, and the height of this triangle is right here, is 8. Okay, so we have 4 times 1/2 times 7 times 8. 4 times 1/2 is 2. And then 2 times 7 times 8. Okay, so 2 times 7 times 8 is 112. So the surface area of all 4 of our triangular faces is 112 centimeters squared. Now we need to find out the surface area of the base, which we said that this was a square pyramid. So here's our square down at the bottom. Area of a square is just side squared, so that's 7 squared. So that's 49 centimeters squared. To find the total surface area, we're just going to add 112 plus 49, and 112 plus 49 is 161 centimeters squared. So we just found the surface area of our square pyramid. Now the last thing we're gonna do is we're gonna do box skill check number 3. We're gonna do number 1 together. So this to me looks like another square pyramid. We have a square down here at the bottom, which means we have 4 triangular faces. Here's 1, here's 2, here's 3, and then this 1 in the back. Here's 4, okay? So the surface area of our 4 triangular faces is going to be 4 times the area of the triangle. So 4 times 1/2 times base times height. Our base is 13, and our height is 17. 4 times 1/2 is 2, so then we just do 2 times 13 times 17, and that gives us 442 centimeters squared. And then we have our surface area of our square down at the bottom. There's just 1 square. Side squared is 13 squared. 13 squared, hopefully you know, is 169 centimeters squared. Add those 2 together to get the total surface area, and you have 611 centimeters squared. Challenge yourself. And you know what? That is actually not number 1. That's number 2 in box skill check number 3. Sorry. That should be number 2. Challenge yourself to do number 1. And hopefully, when you do, you arrive at the answer of 64 meters squared.